Good morning. We're going to continue with the function summary of a rational function, f of x equals x cubed minus 4x squared over x squared minus x minus 4. The next property is behavior toward infinity. This is where we take limits toward positive and negative infinity as x approaches positive and negative infinity, and we find if there's a horizontal asymptote or if there's infinite limits and it's a rational function, we look for another type of functional asymptote, slant asymptotes. So anyway, so we'll just start. It's the limit as x approaches negative infinity of x cubed minus 4x squared divided by x squared minus x minus 12. This is a rational function, and the degree of the numerator is higher than the degree of the denominator. So therefore, it will be an infinite limit. To determine if it's positive or negative infinity, we divide every term in the numerator and the denominator by the highest power of x in the denominator, which is x squared. So we do that. We'll get x cubed over x squared minus 4x squared over x squared divided by x squared over x squared minus x over x squared minus 12 over x squared. With some cancellations, simplification, it looks a little bit cleaner. That goes away. We get an x right there. We get a negative 4 right there. We get a 1 right there. We get a 1 over x there. 12 over x remains, or 12 over x squared rather. As x goes to negative infinity, this x goes to negative infinity. The minus 4 goes to minus 4. 1 goes to 1. 1 over x goes to 0, and 12 over x squared goes to 0. So we have negative infinity minus 4 over 1, and that is equivalent to negative infinity. So we don't have a horizontal asymptote or in the direction of negative infinity. So we're going to definitely need to look and investigate if we have different kind of functional asymptote called it's going to be called a slant asymptote, but oblique asymptote also. I've heard them called. Anyway, so now we take the limit as x approaches positive infinity, and we do the same thing. And in fact, I'm going to just write what we got here. And after we did this step before, we got x minus 4 over 1 minus 1 over x minus 12 over x squared. As we go to infinity, positive infinity this time, this goes to positive infinity, this goes to negative 4, this goes to 0, and this term goes to 0. So we have positive infinity minus 4, still positive infinity, divided by 1 is positive infinity. So we don't have a horizontal asymptote, but we do have, or there's a possibility that we have a different kind of functional asymptote called a slant asymptote, and actually we do. And we're going to do that in the next video, and we're going to use long division to determine that. So the limit as x approaches negative infinity was negative infinity. Limit as x approaches positive infinity was positive infinity. And now we'll go to the next step because I don't have enough room to do it here.